So I think we're ready to launch into this panel. We understand that we are standing between you and lunch, so we'll try to make this as time expedient as possible. I'm Dawn Wright from Esri, also from Oregon State University, and I have the great honor of chairing this panel that is about science with CyberGIS, not the science of CyberGIS that we're going to discuss after Xiaowen's keynote after lunch, but this is with CyberGIS. And by science, I believe we are talking about how the Earth works. So we're talking about Earth processes. We're talking about human influence on those processes and vice versa. We're also thinking about not only how the Earth works, but also perhaps how the Earth should look in terms of how we would design the Earth. And we've seen some nice examples of that perhaps from David's presentation already. I'm going to be wedded to the desk here for the benefit of our remote participants just for a couple of minutes to set the stage for this. And then we will have some comments from our distinguished panel here. So you almost sat in the right order in terms of the listing here alphabetically. Leon is from the Department of Geography at San Diego State. Next to him is Zun Shi from the Department of Geography at Dartmouth. Next to Zun is David, and you already know all about David, a hydrologist, and he's in the Civil Engineering Department at Utah State. And then Wendy Cho is in the Department of Political Science at the University of Illinois Urbana-Champaign, and also a senior research associate at the NCSA. I myself am a geographer and oceanographer, so I think we have a very nice mix of disciplines on this panel with which to discuss science, and I include social science in that realm. When we're talking about science with CyberGIS, we have been talking, especially given Mike's challenge to us yesterday morning, we need the street credibility. We need the respect, the notoriety, the attention of the rest of the scientific community. We've already been through this in terms of geographic information science. We have had the discussions over the years following on from Mike's leading our community, Mike and many others leading our community in moving from systems to science. We've been having the discussions of where is CyberGIS in relationship to geographic information science. I'd like to just point out an effort that actually came out of the Association of American Geographers Cyber Infrastructure Specialty Group, which is interesting in and of itself because that is a new specialty group within the AAG. We were questioned at first as to whether or not we should just be within the GI Systems and Science Specialty Group within the AAG, but we were able to forge ahead and have a Cyber Infrastructure Specialty Group. And one of the efforts that came out of that was to put forward a special feature in PNAS, or PNAS, Proceedings from the National Academy of Sciences. And in that, we sought to talk about the emergence of spatial cyber infrastructure. CyberGIS, many of us would argue, is a subset of broader spatial cyber infrastructure. This was a very important series of papers, we think, and you can grab the entire special feature, open access. This is not an Esri effort, but I used Esri's URL shortener just to make it easier for you to find it. So you can just go to esriurl.com/PNAS. So Xiaowen and I wrote this introductory paper talking about what is special about spatial in terms of cyber infrastructure. And we've already heard about cyber infrastructure from Dan this morning. And then there are several papers that I think will be of great interest to many of us that span several different domains or disciplines. I'd like to point out the second paper, the John Helly et al. Paper, because this paper makes a particularly good argument, I think, for the value added of spatial cyber infrastructure and, if you will, CyberGIS. It's not really a GIS paper, but in that paper, they talk about how the spatial cyber infrastructure that they set up to do a series of investigations in the Weddell Sea in Antarctica actually allowed them to change and to create a new sampling scheme. It's a new oceanographic sampling scheme using a series of research expeditions, a series of sensors. That new sampling scheme actually allowed them to discover a new plume of meltwater coming from a glacier within the Weddell Sea. So they made this new discovery because of the spatial cyber infrastructure that they set up that allowed them to sample in a different way, that allowed them to discover this new physical feature. And then that new physical feature is giving them insights into the flux of carbon all the way from the sea surface down to the sediments on the sea floor. And they cite this in this paper as an example of something that could not have been done without the spatial cyber infrastructure that they set up. So I think that's what we're talking about here with this panel, and hence, this is the overarching question that I've charged our panelists to comment on, and this was also guided by very helpful discussions with Xiao Wen. How does CyberGIS lead to new discoveries in science? And are these discoveries that might not have been possible without CyberGIS? And if you recall in Dan Katz's presentation this morning, when he gave the NSF definition of cyber infrastructure, the last words in that definition were enable breakthroughs not otherwise possible. So that's what we're going to try to tackle in the next 45 minutes or so. And I was going to just let our panelists have a free stab at this. But before we go completely into free flow, I'd like to invite Wendy to come up to present some slides that she has prepared, and then we can go from there and let the other panelists present any comments or insights that they have accordingly. So Wendy, would you like to come forward?
Okay. Thank you. So this is a joint project with Xiao Wen and Yan Liu. And this is a project about redistricting and how a cyber GIS environment will help us understand social science a little bit better. So ever since I was little, I've been fascinated with politics. I mean, really, since I was a little, very little. And it wasn't until I got older that I figured out why. And I think why is because I'm fascinated with this idea of power. How do people obtain power? And how do they keep power? How do they legitimize power? It's like the United States. We've got 300 million people. We're ruled by this government, and we all think it's legitimate, right? We don't revolt against it. We think it's great. We're the greatest democracy in the world, right? We believe that. If you don't believe that, it's okay. But by and large, I think we mostly believe that. And it's fascinating because sometimes I try to explain to my children about other governments, because there's lots of other governments, right? And they're fascinated with this idea of North Korea. Like, how could that happen? How are these people, how can they be ruled by that kind of government? Why is that government still standing? And so, we kind of talk through that, and this idea of power and how it's obtained and how they keep it. So redistricting, this is not the right arrow. Redistricting, I think, is something I'm kind of interested in because it determines power in the United States. So for instance, I'm going to go pretty fast here, but this is just like a hypothetical map. It's a hypothetical state in a rectangle. So there are equal numbers of Republicans and Democrats. So if you want to draw these into districts, you can draw them this way. So you've got one Republican district and 3 Democratic districts. Again, they're the same number of Republicans and Democrats, but if you draw it this way, the Democrats make all the decisions, right? Because they've got all the districts. If you draw it this way, you got 3 Republican districts and 1 Democratic district. Who makes all the decisions? The Republicans, right? Same people, same state, same everything. Or you can draw it this way, and you've got 2 Republican districts and 2 Democratic districts, and then everybody thinks that's fair. Whether it's fair or not, whatever. But I mean, these are the things that are possible. And this is just a really simple example. So in general, people call this gerrymandering, right? The idea is that instead of you choosing your representatives have chosen you, right? They put you in their district, and they make the decisions. So it's kind of like, oh, okay, is that, I don't know what that is, but it's called gerrymandering, right? And in general, if I explain this to you, you think that's bad, right? I don't like that, that's bad. So So we have all these laws in place to prevent gerrymandering, because people think it's bad. But in general, gerrymandering, all these laws and legal constraints, they don't do much. So let me show you some of my favorite districts. This is North Carolina. District number 12 is the one in dark. It's 160 miles. A lot of it goes down a freeway, and once it gets down to a place where it has some people it wants in its district, goes out and gets those people, comes back on the freeway, travels down the freeway, goes to get some more people. And that's the 12. That one's particularly ugly, because I love that freeway thing. But look at some of these other districts. That's what the state of North Carolina looks like. It's been redistricted into seats. This is Louisiana's 4th. This kind of looks like Louisiana, actually, because it's got the top of the state, the side of the state, the bottom of the state. It's all one district. They drew it like that. And by the way, these passed the legal battle, right? This is Illinois' 4th. We like to affectionately call this one the earmuff district, because they really only wanted those people up there and these people down here. This goes through cemeteries, forest preserves, roads, not people, by and large. So they wanted to connect those two populations, and they made that district. Wow. This is one of my personal favorites, Texas 29th. I like this one. It's my personal favorite because it looks like a man falling off a horse. That's why it's my favorite, for no other reason. But again, these are, you know, this is like truth is stranger than fiction. I didn't make these up. These are actual districts, right? And it's just, and I think they're districts that people aren't even aware exist. I mean, I just love the shape of this one. So U.S. elections, when they draw them this way, they're largely non-competitive. I mean, you think, you go to the polls and you vote, you think that's a big deal. The election's not competitive, right? And if you look over time, U.S. House election rates from 64 to 2012, it's really high. I mean, some years we go to vote, there's 435 members of the House, almost none of them get knocked out of office. They all get reelected. Like, okay, why did I go to vote, right? And if you ask my children, they'll tell you that I never go vote because I'm a rational being, because I'm more likely to die on the way to the polls than I am to have an effect on the election. So I don't go because I don't want to die. So that's actually a true story. I don't vote for this reason. So, you know, you look at this, and if you think about it, you wonder, what are the societal consequences of gerrymandering? We know it happens. And what's the consequence of having all these non-competitive elections? These elections where you go to vote, but who cares that you went to vote, right? Because we already knew what was going to happen. We drew that district for a certain purpose, and that thing, whatever it is we drew it for, it happens. That's just true. So I don't know what the impact of it is on democratic rule, because I don't have the counterfactual, right? When you do science, you need a counterfactual. You don't have the counterfactual. You only have what happens. So the only thing I think about this is I recognize that as an important question. You know, what's the impact on democracy? The greatest democracy in the world, the United States. Well, what is the impact there? Is it really a democracy in fact? So mostly we just recognize these as important questions because I don't have any tools to analyze these questions. There's no unified theoretical framework. There are no counterfactuals. What can I do? I don't know. What can I do? I don't know. So the thing that we mostly recognize is this is a very large-scale computational problem, redistricting. So one thing happens, and that's the reality, but there are so many other possibilities for what could happen, but we don't know what those are. We can't analyze them. It's too big of a problem. So a Stirling number is just how you separate n things into k non-empty sets. If you take 55 things and you want to put them in 6 non-empty sets, there's this fairly large number of how many ways you can do that. It's a big problem, right? If you take the state of Minnesota, instead of 55 units into 6 sets, we have approximately 270,000 units that you can put into 8 sets. So how many ways can you do that? A lot, right? And how do we characterize those? I don't know, because we haven't really done it. So one of the things that we've been thinking about this problem is I can't think of any legal constraints. I mean, the lawyers have thought of a lot of legal constraints, and I've been an expert witness on some of these law cases where, you know, people try to toss these out, and those legal constraints just are not binding. I mean, they do nothing pretty much. And you saw those other districts where they weren't doing much, right? We have all sorts of legal constraints in place on what kind of things you can draw. So our approach, instead of talking about legal constraints, is to develop a computational tool. And the idea is to be able to explore what's possible in redistricting. Not to look at what happened, but to be able to explore the counterfactuals, what could exist. So if you want to talk about fairness, are these districts fair, the ones that we have? You have to have some ability to quantify bias, right? And we have no such ability. We don't have any tools to quantify that. We don't know how to talk about that. To talk about competitiveness, you have to know, is it competitive? Like, I don't know. What else is possible? And if you don't know what else is possible, you can make no statement about what exists, right? So what we have now is basically nothing to analyze what we have in redistricting. But if we were to have some type of computational tool that could kind of synthesize all this information and then organize that information, then we could actually sit down and have a conversation about the impact on democracy or what it's doing as far as our representation. Are we being fairly represented, or are we really not being represented fairly at all? And what's better? I don't know what's better. But so this is the project, is we want to develop this tool. And we're just getting started here. So we formulated it as a discrete optimization program. And the idea is, it's right now we're just setting it up with a genetic algorithm. And so we got to move from, we got to move around the solution space. And we don't quite know how to move around the solution space yet. It's actually pretty hard. So we have done some preliminary things on this, but we don't really know how to do it yet. The main problem is it's actually a rugged landscape, but it's a rugged landscape with these huge plateaus. So you think if you have a district and you move just a few units, then it's basically you're still basically in the same place. And so you have to think of some way to make big jumps in between sets of districts, and then how to traverse that entire solution space. It's a big solution space, right? And somewhat idiosyncratic. So we're basically working with a genetic algorithm, and we're trying to use a parallel version of it, so we can look at more things, right? The idea is we look at more options, and then we try to find what's optimal based on whatever it is that you want to examine, whether it's competitive or whether it's something else. So that's the idea behind doing the parallel part. Xiaowen and Yan have been working on a parallel genetic algorithm, and their idea is that they've been working with, so the idea is, how do you communicate between the different processes? And so they've developed this asynchronous migration strategy between the different processes. And they've tested this and gotten it to scale up to 16,000 cores. And we recently got a grant to run this on Blue Waters, which has 40 times more cores. So there's a lot more computation, but then there's a lot more to keep track of, right? So there's a lot of different moving parts here. So one of the moving parts is, how do you scale up to having a lot more processes and then having them communicate with each other and then moving in between them. So this is just the speed up from their paper, just going up to 16,000 cores. So this has got all the right properties, right? It's going faster. It's better than the asynchronous version of the migration is better than the synchronous one at all levels of this, the quality of the solution. And it runs faster. So it's got all the right properties, and we got to migrate that up to more cores. But we're kind of talking about this is redistricting and this other problem, which is just really figuring out how to do more computations with more cores in a parallel fashion, have this nice mutual relationship, right? And the nice mutual relationship is, first of all, redistricting is really interesting, and substantively, it's actually very important. But on a computational front, it also produces this really interesting large-scale optimization instance for Blue Waters, right? And so because we have this large instance, it allows us to learn more about working with PGAs and making them work faster and with more cores. But it also, so that's on the computational front. And so they're kind of like helping each other, right? Redistricting is going to help us learn how to build this environment that will be useful for other things, and this environment that's useful for other things is useful for redistricting. So they're kind of nice that way. So the power of information, I think this is something we've been talking about the whole conference, is the world has undergone this immense transformation, right? And the power of information has extensive and often surprising reach. And I say surprising because, at least in terms of redistricting, if we built this tool and got it perfectly working, I don't even know what the impact of that tool would be. I think it's important to understand democracy and democratic rule and what's fair and what's not fair and how we do things in the United States. But quite frankly, you guys are happy with your democracy and how things are done. And if, you know, stability is produced by slow changes, right? The last thing we want is to say, this democracy, it's not a democracy at all, and we need to do this whole other thing. That's just, that might create widespread riot in the United States. I don't know if it would or if it wouldn't, because I actually don't know what we would learn from developing this tool. But I think without this tool, the ability to understand democracy is greatly hindered, right? The ability to understand what could be in this world, we can't understand that. Without this tool, that piece of social science research is not possible. So that's kind of where we're working and what we're doing. I don't know if it will have a surprising reach or not, but I think it's a cool tool. And I think it would help us organize and synthesize a lot of information to help us understand, you know, a lot of important social science questions.
Thank you very much, Wendy. I'm going to ask you to have a seat back on the panel. And I'm going to ask for applause. And yeah, that's great. This was a wonderful example of what we're talking about in terms of what discoveries or what is not possible without this kind of infrastructure. And I like Wendy's example because she's talking not only about science with CyberGIS, but also I think science of cyber infrastructure and CyberGIS. So in the interest of making this a bit free flow, I'm now going to turn to the other members of the panel to either present your perspectives on this question, or if you'd like to comment on what Wendy has just presented and pick up on that as well, you're free to do that. But Lee, would you look like you're ready to make some comments? So
which would go? So I have some slides, or I can go without slides, whatever you prefer.
I think in the interest of time now, let's just try to keep going in more of a panel format without more formal presentations.
Well, I think Wendy did a wonderful job in presenting her studies related to cyber infrastructure. And I would like to maybe go along that direction, but at the same time present some of my insights. Because for me, from kind of like end users, personally a little bit background, I did some programming in the past, especially in agent-based modeling. And at the same time, I spent lots of time on the geospatial analysis and space-time analysis, for example. Yesterday, Shane presented his research about application of CyberGIS, cyberstructure in epidemiology research. So for me, from my perspective, I'm thinking about one kind of slogan that I have learned when I was a high school student in China. At that time, China still had a communism, ideology, and Marx and Engels were the kind of heroes in our society. I still remember what Engels said. So once a society has a need, then it advances or speeds up the technology or science more than 10 universities. So right now, I think that saying is still, echoing in my mind. So right now, this, cyber GIS science, whatever you call it, science, technology, tool, whatever you call it, I think right now has seen some increasing applications. But still, I'm thinking about from my perspective. Right now, I have a project on golden monkeys protection in China. So we are kind of doing a huge, agent-based models. We, on the one hand, we have a huge number of agents, people household. But on the other hand, we want to represent the environment. No matter these digital animation models or remote imagery, we want to use the pixel as small as possible. But the sacrifice or the downside of that is we increase the amount of data substantially, even exponentially. For example, if we decrease the cell size from 30 meters to 10 meters, then the number of cells is going to be 9 times as much as if we stay at a coarse spatial scale. So in that situation, definitely we actually, at that time I didn't know too much about cyber space or CyberGIS, but we kind of came to the same point as what Selwyn and you guys did. We presented parallel computing. We presented web GIS, web agent-based modeling, because for the local villagers or the local people, if you want them to run ABM on a local computer, it's kind of impossible. But the only thing we can do, probably, we got ABM, we got cyberstructure in our computer. But as long as they have the internet, they can do it. That's one great example, from the application side. The other one, I think that's what I'm also doing, is about a telecoupling project, in which we compare one site in China and one site in Nepal. But right now we're not doing two agent-based modeling. We're doing one. In that situation, we got millions of agents, objects that interact with each other. And I'm also thinking about to use CyberGIS or cyber infrastructure as one of the vehicles that's make this connection possible, because the distance is so far away from each other. There are so many agents. There are so many local stakeholders. So in this situation, I actually, fortunately, I invited Dr. Gochard to be my consultant, and he said yes. And in this PO1 R1 project, I'm thinking about the cyber GIS should be real important or substantial tool in this. So I presented these 3 examples. My point is, on the one hand, we need computer scientists, we need people like cyber infrastructure people, from the technology side. But on the other hand, we probably need people from the application side, like social scientists, ecologists, demographers, political scientists, something like what Wendy just presented. So in this situation, we are kind of approaching the cyber GIS, the science or technology from different perspectives. Mm-hmm. In that situation, we can probably bring up, in the terms of the 5 million users or an average citizen that knows and use cyber GIS, like what we today use Google Earth. This is my, mm-hmm. 2 cents, and after I heard from you guys, and also I have sort of rethought about my project, how in the future we can incorporate or integrate cyber GIS, cyber infrastructure in my research to better serve the society and the people around us. Mm-hmm. Thank you.
Great, thank you, Lee, because I think what you're bringing forward is a very important parallel theme of the interdisciplinarity. Mm-hmm. And then we talked about semantics in terms of our data sets, our ontologies, but there's semantic interoperability that needs to occur between our different disciplines, our different domains. Right. And that's what also struck me about Jun's presentation yesterday, talking about spatial epidemiology, which is an area that I'm not familiar with and don't work with that data. And so, Jun, I wondered if you had comments along similar lines in terms of, you're a hopeful user of CyberGIS, but what I found compelling about your talk yesterday is that you could see the potential for CyberGIS to perhaps answer this question here in terms of you cannot perhaps get to the solutions or the answers that you need without this infrastructure. So
exactly, mm-hmm. Yeah, exactly. And let's back up a little bit, and I want to comment. I really like at the beginning, Dan said, actually you distinguish and build connection between 2 things. First is the science, because this panel, the theme is science, right? Mm-hmm. And at the beginning you comment the science of CyberGIS, and science with CyberGIS. And I believe these two things are closely connected, related.
I'm sorry for the disruption.
Okay. And I think this situation is pretty comparable to maybe 10 years ago, 15 years ago, 20 years ago when Mike put forward GIS, is GI system or GI science. So cyber GIS can itself become a science, or just provide a method, a technology to enhance something else. So I believe the science with GIS and the science of GIS are closely related in the sense that, indeed, without CyberGIS, there's something we cannot do, and provide, say, besides just break certain restriction and breaking certain restriction and the limitation in current method of technology, just provide a new technical methodology or framework. It also brings about certain things that are totally new. It's not just enhancing, but bring something totally new or alternative, maybe not totally new, but alternative thing. And say the presentation in the epidemiology, I consider it a pretty typical example. So with the CyberGIS, we can adopt an alternative approach to something that is originally used another approach. Say all the things I presented yesterday, say disease mapping or detect association, there's another whole different approach, alternative approach in the conventional science, in conventional statistics. There's a very well established, developed spatial statistical methodology for all those purposes. And the limitation for that is the statistics. With statistics, you have to use certain models, certain statistical model, no matter if the Poisson models or normal distribution model. And the reason you have to use those models because you have to simplify. You have to simplify the scenario. You have to simplify your data. You have to simplify your analysis. But that simplification is based on certain assumptions. You have to assume the distribution follow the normal distribution. You have to assume the distribution follow Poisson distribution. But sometimes you cannot really verify that assumption. So that's the limitation with the statistical approach. And with CyberGIS, with the high performance computing, you can reduce the reliance on those assumptions. So you can adopt a totally alternative approach. I just do the empirical thing. I just simulate, I just generate. So ABM, no matter ABM or Monte Carlo, just generate the empirical thing, I just observe. And this is alternative approach is totally different, not totally different, it's quite different from the traditional or conventional approach. And I believe from this perspective, or in this sense, CyberGIS brings about certain scientific things or scientific methodology and totally, in this sense, I see its significance in terms of scientific merit. This is my comment at this time. Thank you.
Excellent, thank you, Jun. And I see a connection between what you've just described in terms of CyberGIS, creating the opportunity for scientists to have new insights, but also freeing them just to do their science.
Yep.
Without, as you mentioned, being weighed down by the assumptions, by all of the details of the statistical models, perhaps. And in this, I see a connection to what David has been telling us in terms of HydroShare and the infrastructure that you have set up for Tau DEM, where it seems very clear that you are making data, computational models easy for scientists to access so that they can just do their science, so that they can just address these viewshed delineation, hydrologic flow kinds of questions. So am I on the right track there?
Well, you're certainly on the right track. I guess when I was sort of thinking about this question of, I guess, science with CyberGIS and thinking I guess, what are the sort of things that CyberGIS can enable? And my initial line of thinking went down the sort of physical geography, Earth systems path, which is where I guess I'm most comfortable. And then I sort of find myself sitting in a panel here with a lot of very different subjects, and it sort of strikes me that systems integration and this whole area of model integration serves to cut across the disciplines, and I think CyberGIS can certainly help. And if we think of humans as sort of part of the system and the roles played on the landscape, which gets back to sort of my interests in terms of hydrology and water, but then it also gets into things like wealth and power and productivity and health. And we have now the ability to bring in those real different aspects of geography that allow us to address things in a much more integrated way than we would have before.
So the idea of wealth and power has many different meanings and themes to many of us, all the way from just trying to get our next NSF grant funded to making sure that our country really works as a true democracy, as Wendy has pointed out. And this is from someone who votes every single time and has never been more frustrated with Congress, but that is a completely different meeting. So thank you to all of the panelists. And what I've tried to do here is just to engender a conversation among us. But now I'd like to throw that conversation out to the audience, and I hope that you've been able to listen and to absorb, and to you're now able to enter into a conversation with the panel. Perhaps there are some questions or some comments or insights, things that you want to agree with, things that you disagree with. We have 15 minutes before lunch, so what are your thoughts? In the back.
My name is Robert Gary. I'm not a part of the grant. I was invited here, so I to comment. I'd like to just point out how important the point that Shu made struck me. Listening to what people are talking about. And then it goes back to the same question that's up there, and then at the beginning of yesterday was about what new scientific discoveries could not have been made without CyberGIS. It's kind of like the case for spatial thinking. Could Watson and Crick have discovered the structure of DNA without spatial thinking? Could Marie Tharp have done what she did without spatial thinking? I don't know. I think you know Marie Tharp.
Yes, thank you for mentioning Marie Tharp. She's the woman who mapped the ocean floor back in the... Anyway, another digression, please.
I guess my comment is, I think, I'll direct this maybe to the PI more than anything. I think you're in danger, you're at risk of undervaluing what you're doing because you haven't created good enough performance measures. It's just my comment. You may be at real risk of doing this, and there are some lessons from history that suggest why. And the example I was thinking of was the American railroads, another major infrastructure. This is the greatest example of somebody attacking this thesis that this was indispensable. So there was this indispensability thesis that historians assumed that the American railroads were indispensable to the growth of the American economy. It's then Robert Fogel, who happened to win the Nobel Prize for this, created what's called the social savings method, and he posed a counterfactual world. So he said the same thing as this: how would the growth of the American economy have proceeded without the American railroads? And what number did he come up with? Between 2.5% and 3% of GNP in 1890. He shattered the indispensability thesis. But now leave it to an historian or an economic historian to miss the major point here, was that he said, oh, and by the way, though, even though the number didn't change, the distribution of agricultural production would be totally different. So the Midwest would not be the agricultural region that it is now. And how could you miss that? So the value wasn't the number, it was the character or identity of the flows of good people, finance, and information that was affected, and that's where the value lies. So thinking of performance, I mean, not just critics pointing out the problem, but thinking of performance measures, at least 4 performance measures came up, which might inform this gap analysis between doing things normally desktop versus doing things in a particularly CyberGIS, not just cyber infrastructure. Oh, by the way, in terms of social savings, the King County return on investment report that everybody points to, there's kind of a sentence at the end which is almost sheepish, which suggests that GIS, the value of GIS in King County was kind of mixed up with the value of computing in general. They couldn't really separate those two. That should be a problem for you to really pay attention to. How do you separate those two? So performance measures, I just wrote down. Two, conceptual change leading to learning is one, and then complexity leading to validity, and I think that was Shun's point to solve this. In the absence of CyberGIS, you have to make simplifying assumptions in your model because you are limited by your computing power. With CyberGIS, you can entertain ill-conceived maybe assumptions because you have the power of computing. How do you measure that gap? Multiply it times all the people who are doing this, and then say this is the true value. If you don't do that, you may be missing the value entirely of this. And the other thing is that in terms of a body of knowledge, so I think you mentioned computer science and then GIS science. Maybe the learning and cognitive sciences should be the third element of that body of knowledge. We talked about processing, so computational analysis and modeling. But then there's the other thing about capturing, so processing and capturing voluntary human subjects, right? Capturing. But this is something else. Let's say you didn't create a model which is really complex, but because it's cyber, you're collecting human-computer interaction data, which then you can feed back to the, say, learner, provide them with a portfolio of what they've done, how they learned, the conceptual change, or the geospatial competencies that they are now learning, prepare them to enter the workforce. So that's another value. All of that, and maybe even something else, changing the character identity, access for underrepresented minorities and stuff, or women and stuff, or something like that. And that's something else. We're changing the character identity of what's going on. Not necessarily, and again, focusing on processing, thinking of history, you know, the railroads, that may be the wrong metric to be focusing on. So when you report back to NSF, was the money well spent? It was, but you don't have the right performance measure. I think that maybe was Shun's point. That's one performance metric that you should focus on.
There must be some reaction to that treatise. Wonderful, thank you.
So in the project, this is because cyber infrastructure is relatively new in the NSF context. I think to the cyber communities nationally and internationally, my assessments were still going through the learning curve to understand what this means. I think there are some excellent points made. People to our project, we did take into account comprehensive metric, which may be somewhat related to some of the comments you made, but that is quite comprehensive. In the PI meeting earlier this year, I went to NSF. The metric within our team we debated about, I wouldn't say it's final, actually was used as exemplar to share with other PIs. I think Dave, you were there, to say, oh, this is a much deeper issue, and there's one project example actually thinking very deeply into how this scientific project ought to be evaluated. But I think this panel that led to your comments and more deeper thinking about how should we value this exercise. I think that's a part of our project. And I could bring up a slide in my talk later today to show you so far, maybe still to a little bit fashion what we have gone through in our thinking is important.
Any other reactions to that comment? My reaction is that we have been talking about interdisciplinarity as well, and broadening our reach to these different sciences, which I think is part of what you're getting at in your comments as well. A performance measure comes from within our community, and with our focus on structuring data, organizing models, providing the computing power to enable scientists, but I think another performance measure is from the outside of our world here in terms of, was I able to answer my scientific question using this? Was I able to make the decision that I needed to? Speaking to Dan and Mohammed's emphasis on tools for decision makers, for policy makers. Is this worth my investment? Is this worth my time? And one thing that Xiaowen and I were talking about briefly yesterday is that sometimes we have to step out into other literatures as well. Our attempt to publish a special feature in PNAS was fraught with peril and extremely difficult. It was guided by Mike as a member of the National Academy. But I think it was a worthy effort. And I think it's something that, we can't always publish something in Nature or Science or PNAS. But in the past, stepping out and trying to publish in other literatures can often, or go to other meetings, present at other meetings, can often be extremely useful as an outreach. So that might be something that we might want to discuss as well. Tim?
I think in this next year, as we move forward, we have a renewed opportunity here to look at evaluation and performance in regards to the educational aspect of the project that we're trying to pursue more. And I'll welcome Robert's input on that, as he's the Associate Director of the Professional Master's Program in GIS with me here on campus, as is Suzanne Davies-Withers over there, the other Associate Director. So the reasons why they're here are invited was in fact to, so the program has a better understanding about how to do evaluation with the nature of the resources that we have available, or possibly could be made available through your insight there yesterday, Dawn, with regard to the kinds of resources. And I really like that idea that David, you brought up, of resources rather than the learning module thing. There's a whole array of different resources. A generic term which goes beyond all of the different things that we call the stuff we're dealing with here. It's a more generic term that works reasonably well. So a systematic approach to doing that should be useful for the entire community, and we look forward to taking a lot of input from this community.
And I think this, our discussion about education has been so valuable because of the awareness that it brings in terms of the students that we're reaching, again, from outside of our own cultures. Even the students who might take a course in CyberGIS. I mean, the students everybody's taking GIS courses now, and we're bringing in students from history, other parts of the social sciences, humanities, in addition to our normal audience of students. So as we get these resources out in our, like in your GIS degree program and in our certificate programs and through our courses, we are going to be reaching out to that next generation that we spoke of before. Are there other comments?
So a question for
Sushil?
Wendy. That was very, very interesting presentation. So I'm wondering what kind of questions would you be asking once you have this done? And how do you validate those?
I think we see it as a tool partly for researchers who want to understand democracy, and partly as a tool for people who want to affect redistricting. Just to say, there are a lot of people out there who are just interested in this idea that, because right now, redistricting in most states is done by the party in power, right? They present it as a bill, they're the party in power, so they have enough votes to pass it, and they never even talk to you. They don't tell the public, they don't do any of that. But if you had a tool and it was accessible to people, it would change the process dramatically, I think.
Right, but before that can happen, there would be a lot of controversies, right?
Yeah.
So see, really, you should address those things, right? And then the first thing that people would do is to attack the solution itself, or the method that one has used.
Yes.
So there must be something sound, which actually also will allow you and to really defend or actually validate how the modeling has been done, how this actually is valid, and all sorts of things that will.
Absolutely. I mean, we don't have a heuristic yet, So once you develop a heuristic, you have to justify it, right? You can't just say, I did it.
I guess, is there a danger that this could be a tool that the party in power could use to refine the art of gerrymandering? I mean, at some level, right now, they map out the districts based on their imperfect knowledge of who they think their voters are. Maybe with this, they can perfect that, and we could persist the.
Yeah, I think that's certainly a danger. I think of this as like open source, right? When you start including more people, what happens? And I don't think that's entirely clear what will happen, because I think the open source phenomenon, I think, is emerging, and I think a lot of people find it surprising that we make so much progress with that. So I don't know if we'll make progress or we'll create chaos. I really have no idea.
I think what you're doing is recreating what happened when GIS started to be used in the redistricting process. In 1990, GIS, that was the first year that it was really effectively used. And what happened was the parties in power used it to their advantage. I participated on a group in Wisconsin, and they tried to equalize it and spread it across. They gave systems to the state funded it, gave systems to each one of the parties, Democrat, Republican, and to the House and Senate, and then they gave one to the public, so they could design their own plans and stuff. And the parties in power used the technology to their advantage to help maintain power. And I think we've seen that in the redistricting process ever since then, that this type of technology, while it provides a lot of capability, it also brings with it the possibility that those people that have access to it can use it to their advantage.
That's certainly possible.
So we don't want to be exacerbating the digital divide. And if this isn't a case for spatial literacy for all, I don't know what is. So I think, Steve, did you want to, and then Lee?
Yeah, just to follow on Lynn's point, I think in some ways the redistricting example is one that is important and accessible, but in some ways, yeah, the technology exists. The same thing in Minnesota, right? It's just given the political restrictions on the process, in some ways the GIS problem doesn't need to be solved in the sense that they can optimize for whatever they want. They'll go to 49.9% African American, whatever. Because that's the only thing that really matters in terms of Supreme Court review. But as an example of a large class of problems, this is the classic regionalization problem, right? Where once how do you allocate any number of arbitrary units in a spatial way while try optimizing 2 or 3 things. And yeah, in some ways I think it'd almost be, I can see having a lot more play emphasizing other problems that run into this. In some ways the redistricting problem is not as important as all the other examples of districtization for the resource allocation and healthcare allocation and that kind of stuff, where you quickly run into some NP complete problem. Once you go over several hundred units, so in some ways the killer app would be the idea of like, oh yeah, we can actually look at all the counties in the United States and come up with a really interesting allocation for X. So I think in some ways, I think you're selling yourself short with this particular use case. Because this use case doesn't actually need this technology. There's about 100 other ones that can totally use it.
Good start, though. Lee?
Yeah.
We'll end with Lee's comment here so that we can proceed to lunch.
Okay, great. Well, I think what you guys have discussed reminded me of one talk that we got at SDSU Geography. We actually invited an S3 scientist, Dr. Pinder Fu. When he talked about the WebGIS, he said right now the users want things to fast, to simple, and to enjoyable. I think this makes me think about what unique contribution the CyberGIS or cyber infrastructure may, contribute to, in terms of theory or technology. Because thinking about one topic like in the power or democracy, because recently we have doing a kind of online search on people's attitudes towards climate change. And using the cyber data we have collected, we have found some tremendous, patterns. For example, in places, with a majority of Democrats, versus the places with a majority of Republicans. They hold quite different, perceptions and attitudes towards, these keywords. Or of course, you may say, well, we can do a regular survey without doing online or this website or Twitter-based service. But these things give you a very rapid, reflections of people's change of attitudes, people's attitudes towards how they think about climate change. Is that real science, or is that kind of politics? People are make up these science to get more money, for example, things like that. So I think CyberGIS or cyber infrastructure help us to get things faster, get things simpler, and get things more enjoyable. I think without CyberGIS or cyber infra, we cannot do this kind of things on on-time, basis. That's my, comment about that.
I think that's a wonderful note, a wonderfully positive note on which to end. And this is the kind of panel with this kind of deep question that we could have a whole meeting on. So I'd like to really thank the panelists for performing so well under duress in such a short period of time, handling this topic, and also to the audience for taking a few minutes to think about this, and hopefully it will inform our discussions after lunch.